Recall, if you will, the char data type. Remember I said char is a data type and it takes up 1 byte of space. So the values that a char can hold are, well, how many distinct values can you hold in 1 byte? Well, you've got 8 bits, so that's 2 to the power of 8 different combinations. 2 to the power of 8 is 256 different combinations. You might need to rewind that and listen to that again. It's 256 different things can be stored in an 8-bit byte. A char is an 8-bit byte. 256 different things. So I guess it's no coincidence that the ASCII character set contains exactly 256 items. Now, what do I mean when I talk about the ASCII character set? Well, I'm talking about the letter A, B, C, D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, all the punctuation characters, and basically anything you can type on a keyboard. How many of them would there be? Well, there's 26 lowercase letters, 26 uppercase letters, that's 52, plus 10 digits is 62, plus about 20 odd punctuation characters, that's about 82. So we're talking about 82 things that you can roughly type on the keyboard. Plus there's a whole bunch of extra characters left over just in case we need them for something. In fact, there are 256 characters in the ASCII character set, numbered 0 to 255. Now, why is it called the ASCII character set as opposed to some other character set? Surely the characters that you define are the characters that you define. How many different ways can you have all these characters? Well, think about it. The letter A, for example, the letter A could be situated at the very beginning of the ASCII character set. We could make character number 0 an A, and character number 1 could be a B, and so on. So the very first 5 characters of the ASCII character set could be A, B, C, D, E. Or you could arrange a character set another way. You could say, well, the first letter is going to be A, and then we're going to put a space, and then the third one's going to be a B, and then we're going to put a tab character, and then we're going to put the number 1, and then we're going to put a 6, and then we're going to put a hash character, and then we're going to put a C. Essentially, you can kind of randomize them a bit. Or you could take the letter A and say, well, I'm going to make this the 60th character of the ASCII character set. What I'm basically saying is there's a whole bunch of ways that you can arrange all the characters that you've got at your disposal. And they've standardized on, well, they're standardized on a couple of them. The ASCII character set is the most popular, numbered 0 to 255. And the very first character is not used for A. The letter A is actually the character number 97, or it's got a numerical representation of 97, which actually means it's the 98th character of the ASCII character set, because if you recall, 0 is the first one. Why is it number 97? Well, that's just where they've decided to put it. And it turns out that B is 98, and C is 99, and D is 100, and so on. Sorry, I'm talking about lowercase letters here, lowercase a, b, c, and so on. The uppercase ones are different numbers again. Anyway, it turns out that only some of the 256 characters in the ASCII character set are printable. Well, I mentioned them before, there's around about 80-something of them. Carriage return is included in that, so is a space character, so is a tab, so, believe it or not, even is the backspace character. All of these are printable characters. You can type them on your keyboard, and they're part of the ASCII character set. Now, here's where it gets interesting. Every character can be represented, the printable characters, many characters that you know already, such as the letters, the digits, punctuation, and so forth, they're simply the letter themselves surrounded by a single quote. That's how you represent them in C. That's pretty straightforward, and C will just work out the ASCII value and interpret that accordingly. Why would the C program ever need to work that out? Well, because these things are not stored as the letter A in the memory of the computer. Remember, the computer is just a series of zeros and ones. 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 0, and so on. So we've got to convert every character into a numerical representation of that character in order to store it. Every single character. Might sound silly, but that's what happens. So when you're actually writing the lowercase letter A, you're actually storing the number 97, an integer 97. Now this is going to strike some people as confusing, but the character data type, char, the char data type is really just a very small integer. It's a 1-byte version of an integer. It's an integer that can only be in the range 0 to 255. The ramifications of this are, well, they're quite interesting and also they're quite confusing. I'll show them to you in an example in the code in a moment, and you'll see that quote A quote, like I've got in that example on the screen, quote A or quote 6 or quote slash or something like that, they can all be represented by numbers as well. It's just that it's much more convenient, much more readable for us to use quote A rather than 97. If I said, okay, I've got a variable that's of type char, and I'm going to call it character, that'll be its name, character, and I assign the value quote A quote to character, that's all obviously quite readable. But if I was to assign the number 97 to character, and I was to come along and read that code that somebody else had written perhaps, and say, oh, they're assigning 97 to this variable called character. I wonder what 97 is. And I might have to go and look it up in the ASCII character table to find out that 97 was really an A. It's much more readable to just put the A there. However, I want to stress that it's actually possible to just put 97, to actually assign the integer 97 into a char data type. The compiler will not complain. It's a perfectly natural thing to be able to do. So this bullet point tells us that there are really a variety of ways that you can assign a value to a char data type. You can type in source code, quote A quote, if, for example, it was the letter A, lowercase. Or you could say that the variable equals 97. That would be just as effective, although not quite as readable. Or you could do this. You could say the variable equals, quote, backslash 97, quote. And that would be another way to represent A. The backslash means we're not talking about a real character here, we're talking about an interpretation of a character. So what happens is if the compiler sees a backslash, it looks at the next character and says, well, what is it? And if it's a digit, in other words 97 or 123, then it interprets that as the ASCII value of the character. I know it's much simpler just to put 123. So most people don't use that particular representation of characters. They actually use other ones, which I'll show you in a second, that are closely related occasionally. Most times people just put 123. There are also some other backslash interpretations, such as backslash n, which we've already seen, which is the new line character. Here's the backslash r, which is a carriage return. Believe it or not, there's two different characters, a carriage return and a line feed, I think they are. I can never remember. They're quite confusing. There's also backslash b, which is the backspace character, backspace. And then if you actually need ever to output an actual backslash character, then you just put backslash backslash, much in the same way that in printf, and you need to put out a percent sign to the screen, you put %%. Okay, now this will test your knowledge as a programmer or as a student of mathematics. If anyone knows base 8 arithmetic or base 16 arithmetic, commonly known as octal or hexadecimal arithmetic, you can represent a character as its hexadecimal or octal equivalent. I'm not expecting here that everyone would know octal arithmetic or hexadecimal arithmetic, and if you don't, well, I'm not going to explain it to you now. But for the people that do know octal and hexadecimal, you'll notice that in this case, in this example, 123, backslash 123, can be represented in octal as backslash 0173. The 0, if you see a 0 immediately after a backslash, it means that the following numbers are in octal. That's important to remember. And in hexadecimal, you put backslash x, which means the following numbers are in hexadecimal. And notice that B is part of the hexadecimal digit set. Some of that may have been completely incomprehensible to you, and it doesn't really matter because this isn't one of the more important parts of C. But if you do know hexadecimal and octal, I just wanted to show you that you can represent these numbers in that way as well. Okay, let's move on and actually have a look at some of those examples. Okay, this file's called ASCII.c, and I'm going to use it to illustrate some of the concepts I was just talking about. I've declared two variables, an integer and a char, and let's see what we can do with those. How about this one? Number equals 97. Okay, that's an easy one. How about this one? Ch equals b. How about this now? Number equals ch. That's a little bit more contentious. I'm taking a character and assigning it to a number. So theoretically, the value inside number is now going to be what? Well, it's going to be b. How do you express that as an integer? Let's have a look. %d. Let's see what that prints us. No errors. Notice that that compiled perfectly okay. There was no issues for the compiler with that. Run it. Number is 98. That's very, very interesting to know that. You can take the letter b, put it into an integer, and get out, well, the integer value. You think that's interesting? Try this. All of those are perfectly fine. In fact, let's first compile that and see if that runs. Yes. Number is 97, and here number is set to A. Okay, now let's try that a little bit differently. 97. Number is, now I'll change that to a %C. That's all I'm changing. Just a %D to a %C. And run that. It's 97, don't forget. We're going to have 97 expressed as a character. Number is A. Interesting. Very, very interesting. You see the complete interchangeability of characters and numbers here? And conversely, we could say ch equals, say, the letter D, and output ch as an integer. Let's try that. And run. Number is 100. Oh, that should say ch is 100. Sorry, I'll change that just so the output is more appropriate. Compile and run. Ch is 100. Ch is D. I want you to see that these are completely interchangeable. All of these will work. So let's try a little hexadecimal. /x. How about 6f? Suppose that'll work. Let's try that. The value of ch is what? Let's have a look. That's 111. Okay, that's 111. Now let's display it as a %C. See what printf thinks that letter is. It's the letter O. Okay, so in case you wanted to know that, that 6f in hex happens to equal 111 in base 10 or decimal, and that happens to be, 111 happens to be the letter O. So now you know. Just wanted to show you these various interesting ways of approaching